Good morning. Listen now. Last two classes we have covered some concept regarding the digital electronics. Those ideas that I will repeat again, then I will start the new concept. Yes, the first idea. Digital electronics. Under digital electronics, we are supposed to think about that, or we are supposed to learn about what do you mean by analog circuits or analog signals and digital signals. Analog signals, any signal can be divided into two categories. One is analog signal, the other one is digital signal. Analog, it varies from 0 to even a fraction wise it's go on changing. 0, 0.1, 0.01, 0.02, 0.03, 0.2, 0.22, 0.24, like that it is go on varying small and small and small amount. That is analog. Whereas digital circuits are not like that. Digital signals, either it is working or it is not working. That's all the principle here. Either it has to show as 0 or it has to show as 1. 1 means it is working. 0 means it is not working. Only two concepts. Therefore, it has been represented by two numerals called by the name the Boolean algebra, that is 0 and 1. That is Boolean expressions that we are writing, Boolean numbers we are writing. Digital signals is represented by 0 and 1. I told you already about almost all the electronic signals, they are all said to be the digital signals, including your audio signals are digitalized. Okay. Even in the case of your audio signals, 1080p, 780p, like that it is coming now, they are all digital signals. 4K, especially nowadays, whatever we are using as 4K signals, they are all digital signals, pure digital signals with a high quality. Okay, MP4, MP3 is outdated. MP4 that we are taking, MP4 also, MP4A, it has been started now. That is audio signals that we are writing in the form of MP4 signals. Okay, any digital signal is represented by 0 and 1. Quickly, I will finish it up. All these things are finished already. 0 representing not working or low, 1 representing high, 0 representing no, 1 representing yes, 0 representing no voltage, 1 representing there is a voltage, 0 representing not working, 1 representing working, 0 representing false, 1 representing true, 0 representing off condition, 1 representing on condition. Any digital circuit, if you are choosing, even computer, your mobile phones, or it is laptops, whatever it may be, all the digital circuits, they are all made up of the smallest circuits called by the name the logic gates. Therefore, we can say logic gates, they are the building blocks of any digital circuit. The logic gates, if you are connecting together two or more, okay, like that, then only we are going to get the digital circuits. Now, Boolean expression means what? Between any logic circuit, if you are choosing, we are supposed to give the input and we are supposed to take the output. We are giving the input and we are taking that one as the output here. Between input to output here, there is a relation. That relation is represented by an expression called by the name the Boolean expression. That Boolean expression, is it true or false? Is it true or false? That can be represented by a table, tabular column. That tabular column is called by the name the truth table. All these things are important for us. Okay, yes, first concept under logic gates. Logic gates, there are mainly 5 gates are there according to your syllabus. OR gate, AND gate, NOT gate, NAND gate, NOR gate. These are the basic gates. And these 2 gates are called by the name universal gates. From these gates, we can get these gates. Therefore, these gates are called by the name the universal gates. 2 or more number of NAND gates. Using that combination, we can get OR gate, or we can get AND gate, or we can get NOT gate. 2 or more number of NOR gates, if you are connecting together in different versions, we can get the OR gate, we can get the AND gate, we can get the NOT gate. Like this we are going to get. Okay, first idea, OR gate. First we are asking about the symbol. Write the circuit symbol for OR gate. This is OR gate circuit symbol. A and B are the inputs. Y is the output. Y is the output. We are writing that one as A plus B plus representing for R. A or B. Y is equal to output is equal to A or B. That is a Boolean expression. This Y is equal to A plus B is called by the name the Boolean expression. This is a circuit symbol. We are asking for 2 marks. Now we have to write the truth table. Truth table, there are 2 inputs, 1 output. So OR gate, it is containing the 2 inputs or more than 2 inputs, no problem. Higher classes, we are putting even 1 more also. C also we are putting. So there are 2 input signal here. 2 input OR gate symbol I have written. 2 inputs, 1 output. 2 inputs, the different combinations I supposed to put. 0 and 0, 0 and 1, 1 and 0, 1 and 1. These are the different combinations, okay, permutations. If both are 0, then A plus B, 0 plus 0 is 0 off, 0 plus 1, 1, it is on, 1 plus 0, 1, it is on, 1 and 1, 1 plus 1, 2 we should not write, 2 we should not write. Either it is 0 or it is 1. Working and working, it is working, that's all. 2 times working, you should not say. Yes and yes, it is yes only. It is on and it is on, therefore this is on. That's all. This is about the OR gate. OR gate, you can observe that if both the inputs are 0, if both the inputs are 0, then only the output is 0. If any one input is 1, then the output is 1. Okay. Next one, AND gate. AND gate, we are asking, write the circuit symbol for AND gate. This is a circuit symbol for AND gate. Inputs, there are 2 input AND gate that I have written. This is the output. Output Y is equal to A dot B. It is a logic multiplication, logical multiplication. This is a Boolean expression. Output. Now truth table. There are 2 inputs here, A and B. There is only one output, A dot B. Y is equal to A dot B. A and B are the inputs here now. The input signals, we are writing that one as combinations, different permutation combinations. We have to give it. Both are 0. Any one is 1. Both are 1. 0 into 0 is 0 off condition. 1 into 0 is 0 off condition. 0 into 1. 0 into 1 off condition. 1 into 1 is 1. It is on condition. So in the case of AND gate, provided if both the inputs are 1, if both the inputs are 1, then only it is the output is said to be equal to 1. If any one input is 0, any one input is 0, then the output is 0. NOT gate or inverter gate. Inverter gate circuit symbol is this. Arrow mark with a bubble we had to write. It is having only one input and one output. This is the particular case in which we are putting only one input. It is a single gate containing a single input and output is there. If you are giving an input as 0, output is 1. If you are giving an input as 1, output is 0. That is the inverter gate combination, inverter gate idea, that is. Truth table, only one input, one output. If you are putting 0, you will get 1. If you are not giving any voltage, voltage is working, it is acting. If you are giving the voltage, it will not work. So it is 0, it is on condition now. If it is 1, it is off condition. That is the inverter gate concept. Okay, next one, NAND gate. Okay, these are all the concepts already finished. NAND gate, it is a combination of AND gate and NOT gate. AND gate output, we are feeding as the input for the NOT gate. So this is AND gate. AND gate output, already we are aware of that one, A dot B. That one we are feeding as an input for NOT gate. NOT gate, whatever we are giving the input, that bar we are supposed to take. If it is 0, this is 1. If it is 1, this is 0. Now, circuit symbol. This is the only explanation I have given that. The circuit symbol combination of these two. Combination of these two, I can write the circuit symbol like this. So AND gate only, that is. AND gate, one bubble we are supposed to put it. A and B, 2 inputs are given. 2 inputs, output is taken as Y is equal to this A dot B bar. truth table. There are two inputs are there. The two inputs I supposed to write, both the inputs. So the two inputs A, B, intermediate output A dot B, grand output Y is equal to A dot B bar. Now this is AND gate actually. This is AND gate truth table. This is AND gate truth table. This is NAND gate truth table. Now here both are 0, 0. Both are 1, it is 1. A into B, 0 into 0, 1 into 0, 0 into 1, 1 into 1. First we had to write this. If it is 0 here, not gate, it is 1. If it is 0, 1. If it is 0, it is 1. If it is 1, it is acting as 0. This is NOT gate idea. This is AND gate. AND gate, NOT gate together. This is NAND gate truth table. Okay, yes. Next one. This is a NOR gate. Last gate is a NOR gate. NOR gate, it is a combination of OR gate and NOT gate. OR gate output, we are feeding as the input for the NOT gate. So this is OR gate. We know that OR gate output is A plus B. That is feeding as the input for the NOT gate. NOT gate output is equal to the input of that bar. A plus B bar. If this is 0, this is 1. If this is 1, this is 0. So this is OR gate and this is NOT gate. So here OR gate, it has been followed by a NOT gate. Output is equal to this. So circuit symbol, if they are asking in the examination, don't write this. Write this directly. OR gate with a bubble. NAND gate means AND gate with a bubble. So there are two inputs. This is output. Truth table also we are asking. So what is the truth table? A, B, two inputs. Both are 0. One is 1. Both are 1. Now this is A plus B. Here, this is A plus B. This A plus B we are supposed to write. This is the output for the OR gate. This is output for the NOR gate. Now 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, not 2, 1 plus 1 is equal to 1 only. On plus on, it is on only. Now this is 0, therefore this is 1. This is 1, therefore it is 0 because it is inverter circuit. It is not gate. It is a NOT gate. 0, this is 1. 1, this is 0. This is 1 and hence it is 0. This is 1 and hence this is 0. This is about the NOR gate. Okay, up to here already 2 times it has been explained. Okay, 2 days, this is the 3rd day it has been explained. Okay, the whole one concept is finished. Okay, continuation of not this concept, electronics concept. First idea. I will start with the atomic physics concept. Again, atomic physics already finished. How many of you are already understood or how many of you are already forgotten? I don't know that. Okay, atomic physics you should not forget. So according to the atomic physics, either it is Thomson model, Bohr's theory, Rutherford's model, then Bohr's theory. Okay, already we have come across about all the concepts. Now, according to your Bohr's theory, if I'm choosing, nucleus is present here. Electron is revolving around the nucleus. This is electron. This is already, we are aware of that. Okay. Nucleus is present, which is carrying the positive charge. Electron, which carries the negative charge, which is revolving around the nucleus in a circular path with a radius is equal to r. This is an atom. Atomic model. Already we have learned about this atomic structure. This is said to be an atom. Now let us consider any crystal. I will switch over to the atomic physics to electronics. I will switch it over now. Let us understand about the atomic physics. Then we are supposed to understand about the electronics portion. Slowly we are transit from atomic physics to electronics portion. So first concept, an atom, basically it is having a nucleus which carries the positive charge, electron which carries the negative charge, which is revolving around the nucleus. either in clockwise or anti-clockwise, whatever it may be. Take your atomic physics notes and read all these concepts again. Now, let us consider any crystal. I will going to consider any solid material. I will consider a solid substance. It may be a crystal, germanium crystal, silicon crystal. They are all made up of its own atoms. If this is a crystal, this crystal is made up of its own atoms. Its own atoms means if it is germanium crystal, germanium atoms are present. If it is a silicon crystal, silicon atoms are present. Then atoms, are they less in number? No, they are all huge in number. I said already, 1 gram mole, it is containing 6.023 10 to the power 23 atoms. 1 kg mole, it is containing 6.023 10 to the power 26. Imagine that. I'm not bothering about 6 point something. I'm bothering about 10 to the power 26 atoms. Kg mole, if you are choosing, 10 to the power 26 atoms are there. It is a huge in number. These atoms, they are all closely packed up here. Closely packed up. Let us consider like this. This is one nucleus. Electron is revolving. This is another nucleus. One more atom. Electron is revolving. One more nucleus. Electron is revolving. Not one electron actually. There are so many number of electrons are revolving. You are aware of that. 1s2, 2s2, 2p6, 3s2. Like that, the different orbits are having the different number of electrons. Electrons are go on pairing up. So different electrons are there. I am writing only one orbit here. Actually, it is not one orbit, not only one shell. It is containing so many number of shells. But each atom is having the same number of electrons here because it is made up of the same type of crystal. Crystal we are not changing. Germanium means it is having its own number of electrons. Silicon means it is having its own number of electrons. Now, let us consider one more nucleus, electrons are revolving here. One more nucleus, electrons are revolving. Like this. Everywhere it is present like this. Everywhere. Now, in chemistry, already you have studied about the valence electron. Valence electron. First concept, what do you mean by this valence electron? Now, let us consider any atomic structure. Any atomic structure I will consider. Maybe I will consider as an example, lithium I will go into consider. Lithium 3, atomic number 3. Mass number it go on varies according to the isotopes. Maybe it is 6, maybe 7, whatever it may be. So lithium 3 is the atomic number which is containing 3 number of electrons. The atom, it is containing 3 number of electrons. I'm not talking about the nucleus. Nuclear physics also finished. Lithium 3 containing 3 number of electrons. It is having 3 electrons. Okay, this atom, it is containing 3 electrons. The 3 electrons, how we are writing here. So see that this is lithium nucleus. This is electron. Maybe it carries the 2 electrons here. The remaining 1 more electron is moving here. 1, 2, this is the 3rd electron. The outermost orbital electron, this is called by the name valence electron. Easily detachable from the nucleus. Easily it can be removed from the nucleus. Just like in your classroom, this is the board where the teacher is standing. Okay, these are the students who they are all seated closer to the teacher. They cannot escape easily. But this is the student who has seated nearby the doors. Easily he can escape. Therefore, most of the occasion, the teachers, they are not concentrating here. They are concentrating only the outermost orbital electrons. Because at any time they can go out. Okay, this is valence electron, outermost orbital electron. The outermost orbital electron, it is detachable easily from the nucleus. If you are giving a small amount of energy, it can move it outside the particular orbit. Okay, it can move out particular orbit easily. So that is a detachable electron. It is a detachable electron. That outermost orbital electron is called by the name valence electron. This is the outermost orbital electron. So meaning a valence electron means it is an outermost orbital electron. Everywhere valence electrons are present here. Here also there is a valence electron, here also valence electron, here also here. For example, let us consider one more lithium atom if I'm writing. This is one more lithium atom if I'm writing. This is the nucleus. These are the two electrons. Two electrons are revolving here. There is a third electron, it is revolving. Now you see that this valence electron is, if it is coming here, this valence electron is coming here. This valence electron of the two different atoms, they are close to each other. Whereas these two electrons and these two electrons, they are not very close to each other. I hope you understood. One classroom, one student who is coming out, another classroom, a student who is coming out, they are very close friends. They are close friends. But these K-shell electrons, they are not. These electrons attached to this nucleus, these electrons strongly attached to this nucleus, not so easily it can be removable. But this electron can be easily removable. But this electron and this electron, they are influencing with respect to each other. Here, these two electrons and these two electrons, influence will be there, but the lesser amount of influence is there, because here to here, longer distance is there, but here to here, closer distance is there. Therefore, I require valence electrons only. Okay. Now, going back to the atomic physics concept, you have understood what is valence electrons. Now, let us consider the atomic energy. If I'm considering any electron which is revolving around the nucleus, this electron is having an energy. Already we are aware of that energy. En is equal to minus mz square e to the power 4 divided by 8 n square h square epsilon naught square. Derivation is finished. Take your atomic physics notes and see that it is having an energy. Every electron, if it is revolving around the nucleus, it's having its own energy. It is having its own energy. It is having an energy level. It is having an energy level. I'm saying it is an energy level. Energy level of this electron. Energy level of this electron. Something else is present here. En. Now, apply these ideas to the electronics portion now. Okay. What is electronics portion that states? I said already, atomic physics to electronics, that we are switching over. We are having a transition from one chapter to another chapter. This is atomic physics. This is atomic physics. Now, slowly we are switching over to electronics portion. What is this? Now, let us consider any crystal. Either the crystal, either it is germanium or it is silicon. Let us choose. Either it is a germanium crystal or silicon crystal. Afterwards, you can ask why we have chosen germanium and silicon only. Okay, that is different case. Now, let us consider here germanium or silicon crystal. Now, this crystal, if it is containing this germanium crystals, it is containing germanium atoms. Silicon crystal, it is containing silicon atoms. All these atoms are closely packed up. If they are all closely packed up like this is a germanium crystal. This is nucleus. Electron is revolving. This is nucleus. Electron is revolving. Outermost orbit. Valence electron only that I am taking. This is nucleus. Valence electrons are revolving. Nucleus and valence electrons are revolving. These are the valence electrons. I'm not talking about the innermost orbital electrons. I'm talking about the outermost orbital electrons. Now, the outermost orbital electrons are called by the name the valence electrons. one atom valence electron, it's having its own energy. Its own energy. This energy influenced on this energy. Now, this is also having the same amount of energy. The same way, because this is one atom, this is another atom, this is another atom, same germanium atom only. Therefore, this electron is having this energy. This electron is also having the same amount of energy. Whereas this electron interacting with this electron. This and this, they are interacting. Interaction is more here. I told you why it is interaction is more. Okay, the force with which whatever they are acting is said to be the more here because these two are close to each other, not the innermost one. I'm not talking about the innermost orbital electrons. I'm talking about the outermost orbital electrons. If the outermost orbital electron is coming here and if it is coming here, these two are very close to each other. These two are interacting with respect to each other. If they are interacting with respect to each other here, this energy level splits up into two energy level, but they are close to each other. These two are very close to each other. Now one energy level divided into two because of these two interactions. I hope you have understood. This energy, afterwards you can ask the question, no problem. This energy, this electron interacts with this electron and hence one energy level splits up into two. Now this electron interacts with these two. This is also interacting. This electron is also interacting. Like this, here there are 10 to the power 26 atoms are there. If I'm considering 10 to the power 26 atoms are containing 10 to the power 26 electrons or more than that, they are all interacting. They are all interacting. I'm talking about only valence electrons. All the valence electrons in that germanium crystal surrounded by each other, they are all interacting one to one to one to one. They are all interacting. And hence the energy level, they are all going to get splits up into so many number of energy levels. Electrons are repelling, but they are all repelling here only, here to here. That is a force that I am asking. Either it is a force of repulsion or something else, whatever it may be. But don't forget, if these two electrons are repelling, there is a force of attraction is more here. Don't forget, it cannot move outside the, atom. It has to be revolving around the nucleus only. Because electron to the nucleus, there is a stronger force is there. Okay, nucleus is carrying the positive charge, this electron carrying the negative charge. This electron belongs to one atom, this electron belongs to another atom. This electron and this electron, they are interacting. Interacting means there is a force that is acting. Due to that force, interaction means it is a type of fighting, I can say. Okay, due to that interaction here, one energy level splits up into two energy levels. This electron also interacting here. This electron is also interacting. And now 4 valence electrons are interacting here, divided into 4. Like this, 10 electrons are interacting, divided into 10. But they are all closely spaced. Sir, what is the difference between here to here? Very infinitesimally very small. Almost equal to each other. But I have written a bigger line here. Therefore, one energy level divides in the form of so many number of closely spaced, very small difference in the energy levels. Like that, it has been divided. This is called by the name energy continuum. Just I am introducing the concept. This is called by the name the energy continuum. This is also called by the name energy band. B-A-N-D. It is not B-O-N-D. It is not bond. Okay. Chemical bonding is there. That one we can discuss tomorrow. Okay. This is energy band. It is a band theory of solids. In higher classes, it is called by the name the band theory of solids. But we are not going to discuss like this. We are going to discuss in more detail about this band theory. Higher classes. Okay. How they are interacting. Then interaction between this closed one. What is that? Innermost orbital electrons are also there is an interaction. But these interactions are said to be the less. These interactions are less, but interaction is more only for the outermost orbital electrons. They are called by the name the valence electrons because they are close to each other. Therefore, energy level, it has been divided into so many number of energy levels. They are all closely spaced energy levels. These energy levels together is called by the name energy continuum, is also called by the name energy band. Energy band. This is due to the valence electrons only. This is due to the valence electrons only. Hence, this is called by the name valence band. This band is also called by the name valence. Sir, why it is valence band? Because of valence electrons only. Okay, understood. Next one, another 5 minutes time is there. One more concept that I will going to discuss. Then I will ask you the doubts or something. Just another 1 or 2 minutes. This is valence electrons. Due to valence electrons, whatever the energy continuum we are getting, whatever we are getting the energy band, whatever we are getting, that band is called by the name valence band due to valence electrons. Okay, now let us give some amount of energy from outside. Okay, if you are giving energy from outside here, for example, this is a valence electron. I told you here, this is a valence electron, loosely bound. A student who is seated far away from the teacher, means last bench, closer to the door, who has seated. Any other person who is coming here, influencing on him, so that he will go out. Lesser energy is required. This requires lesser energy to move out, but not this. Okay, here this electron can easily move because of external energy. Either some voltage it has been given, current it has been given, heat energy it has been given. You see that heat energy is given, voltage is given, or current it has been given, so that this electron can be easily removed. If it is easily removed here, now it is coming out of this orbit. It is coming out of this orbit. If it is coming outside the orbit here, it is coming outside the orbit. Now, this electron is not called by the name the valence electron. It is called by the name the conduction electron. Just like this is a student, let us consider, is a student of 10th standard SSLC. As long as he is present in the SSLC, he is SSLC student. No, sir, he has passed out. He has passed out. No longer he is a SSLC student. Now he is a college going student, first PUC student. Then who are first PUC students? First PUC students who they are all passed out the SSLC. Then who they are called by the name the conduction electrons, who they are all removed from the valence electrons. Basically they are valence electrons only. So therefore, a valence electron, if you are removing from that orbit, it can move from one atom to another atom. It can conduct either heat energy or electrical energy. If it is conducting means, which is moving? Electron is, which electron is moving? Outermost, which is that? Valence electron. Valence electron, if it is revolving there only, it is valence electron. If it is removed and if it is moving from one atom to another atom, if it is moving from one atom to another atom here, if a valence electron is removed and moving from atom to atom here, now that is called by the name conduction electron. That is called by the name the conduction electron. Here, due to the valence electrons, there is an energy band called by the name valence band. Now let us consider we have given the extra energy here, heat energy, or maybe the light energy, or maybe the electrical energy we have supplied. These electrons are removed. Which electron? Some valence electrons are removed. Some valence electrons, whatever it is removed here, that valence electron, whatever it is removed here now, this removed valence electron is called by the name conduction electron. They are called by the name the conduction electron. These conduction electrons, one by one, they are all interacting. If they are all interacting, they are also having an energy continuum. If they are having the energy continuum here, now that energy continuum due to the conduction electrons is called by the name conduction band. Now the question is, what do you mean by conduction band and what do you mean by valence band? Valence band, it is another energy continuum or energy band. It is produced due to the valence electrons only. If the valence electrons are removed from that orbit, no longer they are called by the name the valence electrons, they are called by the name conduction electrons, because they are conducting the heat energy, conducting the electricity. These conduction electrons, they are all interacting. They are all interacting. This is one more conduction electron, one more conduction electrons, if they are present here. These are all interacting, and hence the one energy level, it has been splits up into or divided into closely lying very large number of energy levels here. That band is called by the name conduction band. Therefore, we are having the two types of electrons. One is the valence electron, the other one is conduction electron. Due to valence electrons, an energy band we are getting, valence band. Due to conduction electrons, we are getting another band, is called by the name the conduction band. So conduction band is one, valence band is another. Okay, up to here I explained. Tomorrow I will continue about this. These are all the basic. I told you already, if you are having